Hello students, in the previous session we discussed about circles and general form of equation of circle. Here in this session we shall solve some examples of various types involving various conditions, like on finding the equation of a circle satisfying some given geometrical conditions. Let us solve an example. Find the equation of the circle which touches the x axis and whose center is 3, 4. And in the second part we will see the equation of a circle which touches both the axes whose radius is 5. Now, let us look into the solution. Clearly, in the first part radius Cp is equal to 4 as you can see in the figure, and the coordinates of the center are 3, 4. Hence, the equation of the required circle is x minus 3 whole square plus y minus 4 whole square is equal to 4 square, which can be simplified as x square plus y square minus 6x minus 8y plus 9 is equal to 0. For the second part, clearly the coordinates of the center are 5, 5 and radius is equal to 5. So, the equation of the required circle is x minus 5 whole square plus y minus 5 whole square is equal to 5 square. So, we can solve this to get x square plus y square minus 10x minus 10y plus 25 is equal to 0. Since the circle may lie in any one of the 4 quadrants, so there are 4 such circles. The equations of these circles are given by x square plus y square plus or minus 10x plus or minus 10y plus 25 is equal to 0. Let us solve one more interesting example here. Find the equation of the circle which passes through 2 points on the x axis which are at distances 4 centimeter from the origin and whose radius is 5. Look into the figure. We have here 2 circles touching the x axis at points a dash minus 4, 0 and a 4, 0. Center is at C 0, 3 and C dash 0, minus 3 and the radius is 5. As it is evident from the figure, there are 2 circles which pass through 2 points A and A dash on x axis which are at a distance 4 from the origin. The centers of these circles lie on y axis. In triangle OAC, AC square is equal to OA square plus OC square, that is 5 square is equal to 4 square plus OC square, which can be simplified as OC is equal to 3. So, the coordinates of the centers of the required circles are C 0, 3 and C dash 0, minus 3. Hence, the equations of the required circles are x minus 0 whole square plus y plus or minus 3 whole square is equal to 5 square, which on simplification can be written as x square plus y square plus or minus 6y minus 16 is equal to 0. Let us look into another example here. Find the equation of the image of the circle x square plus y square plus 8x minus 16y plus 64 is equal to 0 in the line mirror x is equal to 0. We can see in the figure here, we are having 2 circles which are touching y axis, and in the solution we can see the equation of the given circle is x square plus y square plus 8x minus 16y plus 64 is equal to 0, which can be expressed as x square plus 8x plus 16 plus y square minus 16y plus 64 is equal to 16. Did you notice what did we do here? We have added 16 on both the sides in order to simplify and write down as expansion of binomial x plus 4 whole square plus y minus 8 whole square is equal to 4 square, which can be expressed as x minus 4 whole square plus y minus 8 whole square is equal to 4 square. Clearly, its center is at minus 4 comma 8 and radius is 4 when we compare it with the general equation of circle. The image of this circle in the line mirror has its center C1 at 4 comma 8 and radius is 4. So, its equation is x minus 4 whole square plus y minus 8 whole square is equal to 4 square, which can be simplified further as x square plus y square minus 8x minus 16y plus 64 is equal to 0. Now, let us look up into another example. Find the equation of the circle whose radius is 5 and which touches the circle x square plus y square minus 2x minus 4y minus 20 is equal to 0 externally at the point 5 comma 5. We can see in the figure here. The equation of the given circle is x square plus y square minus 2x minus 4y minus 20 is equal to 0. Its center is C1 1 comma 2 and radius is 5. This circle touches another circle of radius 5 externally at point P, that is 5 comma 5. Let its center be C2 with coordinates alpha and beta. Clearly, P 5 comma 5 is the midpoint of C1 C2. Therefore, alpha plus 1 upon 2 is equal to 5 and beta plus 2 upon 2 should be equal to 5. On solving, we get alpha is equal to 9 and beta is equal to 8. Hence, the equation of the required circle is x minus 9 whole square plus y minus 8 whole square is equal to 5 square. Now, let us see into another example. Find the equation of the circle of radius 5 which lies within the circle x square plus y square plus 14x plus 10y minus 26 is equal to 0 and which touches the given circle at the point minus 1 comma 3. See the figure here. We are having one circle with center C1 and points are minus 7 comma minus 5 and another circle with center C2 which is touching the previous circle at point P, that is minus 1 comma 3. Now, let us look into the solution. The equation of the given circle is x square plus y square plus 14x plus 10y minus 26 is equal to 0. Its center is at C1, that is minus 7 comma minus 5 and radius is equal to square root of 49 plus 25 plus 26, that is equal to 10. The required circle touches the above circle internally at P, that is minus 1 comma minus 3 and has radius equal to 5, that is half of the radius of the given circle. So, its center C2 is the midpoint of C1P. Therefore, coordinates of its center are C2, that is minus 4 comma minus 1. Hence, the equation of the required circle is x plus 4 whole square plus y plus 1 whole square is equal to 5 square. Here we have another example which speaks of a circle which has radius 3 units and its center lies on the line y is equal to x minus 1. Find the equation of the circle if it passes through 7 comma 3. In the solution we have the coordinates of any point on the line y is equal to x minus 1 can be taken as t comma t minus 1. So, let us see t comma t minus 1 be the center of the required circle. Its radius is 3. Therefore, equation of the required circle is x minus t whole square plus y minus t minus 1 whole square is equal to 3 square. Take this as equation number 1. It passes through the point 7 comma 3. Therefore, 7 minus t whole square plus 3 minus t minus 1 whole square is equal to 3 square, which on simplification can be written as 7 minus t whole square plus 4 minus t whole square is equal to 9, which on simplification can be reduced to t square minus 11t plus 28 is equal to 0. This is a quadratic in t here. We find that it can be factorized as t minus 4 into t minus 7 is equal to 0, which on simplification gives t is equal to 4 comma 7. Substituting the values of t in equation 1, we obtain that the equations of the required circles are x minus 4 whole square plus y minus 3 whole square is equal to 3 square and x minus 7 whole square plus y minus 6 whole square is equal to 3 square. Let us solve one more interesting example here. Find the equation of the circle which touches the lines 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0 and whose center lies on the line 2x plus y is equal to 0. Look into the figure here. We find that these are the lines 4x minus 3y plus 10 is equal to 0, which is touching the circle at point P, and there is another line 4x minus 3y minus 30 is equal to 0, which is touching the circle at point Q, and the circle has center at C, which has a line which is touching the other two lines at points A minus 1 comma 2 and B at 3 comma minus 6, and the equation of this line is 2x plus y is equal to 0. Now, let us look into the solution. Clearly, the lines 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0 are parallel and are touching the circle. It is given that the center of the circle lies on the line 2x plus y is equal to 0, which intersects the line 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0 at A minus 1 comma 2 and B 3 comma minus 6 respectively. Therefore, the center of the circle is the midpoint of AB. So, the coordinates of the center are 1 comma minus 2. Let D be the distance between parallel lines 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0. Then D is equal to 10 minus 30 upon square root of 4 square plus minus 3 whole square, that is equal to 8. Therefore, radius is obtained as half into PQ, that is equal to 1 upon 2 into D, that is equal to 4. Hence, the equation of the circle is x minus 1 whole square plus y plus 2 whole square is equal to 4 square. So, students, we have looked into many examples for solving the equations of circles. In the next session, we shall discuss about the general equation of a circle. Thank you.